So I think it was, thank you Petra, thank you Frederick for having me here. It's very exciting. I like the question, what did I do in 1995? It is far less glamorous. I was in the forest doing the Swedish military service. So today I have a great opportunity to talk about smart connected products and operations. I am from a company called PTC. We are a software technology company with global coverage. Our headquarters is based in Boston, and we are soon going to move into the Boston Seaport, where we are finalizing our new headquarters. We have several brands. You may have heard about Creo, Windchill, ThingWorx, and Vuforia. They are all to unleash industrial innovation for the segments that we are serving. Today, I want to start talking about how we see the world is changing. We have done research with Harvard and PTC the last decade. So therefore, we want to share what we have published in the Harvard Business Reviews with you. After that, I would like to take it a little bit more practical to see the key trends and the business benefits of them. And after that, how do we all make this happen with a digital transformation? So let's start with the changing world. What is Industry 4.0? What is the fourth industrial revolution? Here is a quote from the founder and executive chairman of the World Economic Forum, and I think that is very insightful. So he says basically that the fourth industrial revolution builds on digital, and it converges technical solutions into something that breaks the boundaries between physical, digital, and biological. So basically, he said, Industry 4.0 builds on the third industrial revolution about computers and digitalization. In the same way, it's easy to see that the third industrial revolution built on the second one, which built on the first one. So each of these gives technical step changes in our communities. They've happened in an interval of centuries, but the speed is going up, so they come more frequent and frequent. So basically, with these step changes, businesses have new opportunities. They also transform our economic systems. So they allow us to have role-specific optimizations for the machines. With electricity, we could start mass produce. With digital, we could do higher automation and customization. And now we are in the fourth era. It's typically an easy icebreaker to talk about Industry 4.0 because you ask the audience if everyone has heard about it. Yes, that's the case. And then you ask if someone is willing to explain it, and you typically just get the laughter. So I think the first three ones is much easier to understand and internalize. But what actually is the fourth industrial revolution? So here today, I would like to start to peel the Industry 4.0 onion and go down layer by layer. So let's first start building on digital. What does this actually mean? And instead of me explaining this, I invited virtually a customer of ours, Phoenix Contacts, to describe this for you.
Digitalization is one of the most important driving forces for technological trends and new developments. The networking of machines and systems, as well as gathering information on basic and status data of devices, forms the basis for that. The added value this data provides is demonstrated in Phoenix Contact's in-house tool shop. Thanks to the comprehensive networking of all machines and tools in production, setup times of injection molding systems can be reduced significantly. Every workspace offers access to tool data and databases with animations and 3D models on every tool. In addition, toolmakers can also use augmented reality systems that facilitate processes and reduce the error rate. That's how the complex injection molding tools can be classified immediately. Sprue runners, heating and cooling circuits, as well as the optimum tool temperature are indicated, precisely where they are located. The facility management in Bad Pyrmont also uses AR technology today. The required data is provided by Emalytics, the Phoenix Contact Building Management System. Thanks to the intelligent networking of the entire building technology, every user has access to the right information at the right time. External maintenance personnel is led independently and informed about everything that is important in the event of a maintenance work. Controlled safety instructions are given directly on the spot, immediately before use. With the high level of data depth, Emalytics creates transparency. Augmented reality technology makes it possible to experience this transparency. If you are also interested in experiencing augmented reality with regard to Industry 4.0 and building technology, come and visit us at one of our sites. Together with you, we develop your own digitalization strategy, from production to the intelligent building.
Okay, so the opportunities with digital is actually endless. Let's describe now a little bit on the research that we have done together with Michael Porter at Harvard. We started this in the beginning of the decade. So after a couple of years, we published that result in the Harvard Business Review. And in the material you will receive from Petra, you will have links and ability to read the full report. But the first article we wrote was about how products are changing. So our first customer was John Deere in the United States, and they do agricultural equipments like tractors. So in the 80s, the tractor was completely mechanical, even if you did the design processes in 3D and you did manufacturing with NCs and digital equipment. What happened quite long ago is that you added electronics and computers to the tractor, so it got smarter. After that, you also made the tractor able to talk to the outside and got an even smarter and connected. So this is what we call smart connected products. And this is actually a game changer. It's actually quite difficult to see directly how impactful a smart connected product will be. Because in the next step, you go to a smart connected operation. So if you have a smart connected tractor, it can talk to the smart connected harvester or combine. So basically, when the combine goes over the field, it can recognize how many kilo of harvest it does per square meter. And this information can actually then go back to the tractor and say that you need to change how you fertilize this area of the field for more or less. Did you use the right amount, or did you use too much or too little? So basically, the smart connected operations with just two smart connected products with their utilities has a huge potential. And in this step, we talk about product as a service, because now we are starting to see what do we actually do with the products. So it opens up a new way to engage with your customers. However, the next step is going to systems of systems. And this is basically also a macro trend going to an outcome-based economy. So what is an outcome-based economy? So in the farming case, the farmer wants to optimize the profit of his land, meaning that for a multi-year cycle of different crops, he wants to get the maximum yield from each acre of land. So this is his outcome-based economy. And basically from this outcome-based economy, he can now easily to his farming system add other systems, therefore systems of systems, like weather forecasting, a very complex system that can help him planning his own work. Or he can add very small things, like sensors to see if he needs to change his irrigation to maximize his outcome and results from the growing process. Or there is an opportunity for companies doing entirely new models, like seed producers selling the information of which seed, soil, and fertilizers go well together. So it's a digital company doing something that didn't exist in the previous non-outcome-based world. And all of this starting then what we say about building ecosystems. So what is then ecosystems? Yeah, because companies can have different roles in this outcome-based world. So a little bit earlier this year, we had a conference in Stockholm, and we invited two of our customers, ESAB and Quant. So ESAB is doing welding equipment since 100 years. They use digital to do smart connected products, because if they have their products being easier to be used in the outcome-based manufacturing space, they will grow market share. Quant is former ABB Full Services. They sell maintenance since 25 years. But what they do today is that they can go in and do a service level agreement on other people's hardware and manage the planning of execution, buying the spare parts, etc., and so on. So they do a power by the hour kind of methodology in this world. So we have in the articles here more examples on how this impact the strategies. What we also see then is that the value of an industrial innovation platform grows. If you have other ecosystem players than your own company, how do you work together and how do you get this benefit? Because I think McKinsey did a study a few years ago that 60% of the value of IoT comes from interconnectivity with others. And it is the same thing as Fredrik started to talk about, the customer centricity and so on. What we can't see in this picture is the smart connected supply chain. But the smart connected supply chain works also as the value of the innovation platform. It increases the further to the right that you go. And also a little bit provocative is that when we talk product development, it's probably the left half of this picture. If we go to the right half of the picture, the question is if product development will be relevant or if it is sufficient, because you need to design the processes and the outcomes. Okay, easy concept to understand, but quite difficult to realize. So we also analyzed for a few years how companies succeed getting to the right. And we see that they do this stepwise. They don't like wake up just fully fledged and do this. They do it stepwise. So in the smart connected world, you first do monitor, then you do control, and then optimize, and then automate. You can't really leapfrog. You can, of course, increase the space of or reduce the time going from monitor, control, optimize, automate, or even do all four of them at once. But you can't really leapfrog one of the steps. They build on each other. So let me take a more concrete example. Every one of us has parked a car. So we have the gates to the parking house. They open and close. You can monitor if it opens and closes and get the signal. And just by monitoring, you can react. If your parking house doesn't open and close, probably something is wrong, and you can ask someone to go, and maybe you find a congestion that can be removed, and people can go to your parking garage again and pay you money for parking their car there. So just by monitoring, you can actually have a business impact directly. But you need to have manual intelligence and labor on it. After that, of course, if you have the parking house next to a mall, they are typically several stories, and you have probably seen that they close off floors that are full or almost full, and then you need to go higher. So you are actually controlling the flow in your parking house. So the value here is probably not, I mean, yes, you get a little bit more people parking in your parking house because of utilization, but the higher value is to an adjacent system. It's to the mall. If it's easier to park at your mall, the mall will sell more. And as a parking provider, this is kind of a great business value to your true customer, the mall. Now, going to the next step is optimizing. And you know, optimizing doesn't need to be advanced algorithms by computers. It can be displaying the right information to humans. I think everyone have seen this parking lot saying, how many places do I have left in the parking places around or parking houses around the city? Do I feel lucky? Do I go to the closest with 2 parking lots, or do I go 5 minutes longer to the one with 200? So you will optimize the flow of cars in the city, reducing congestion, reducing exhaust and actually have a great impact. And this is what I want you to take away from this page, that we said digital, physical, and human worlds and convergence. We need to do our systems for better decision-making for the humans. We need to put the humans in the center. Yes, in the future, we will have automated self-driving cars. Tesla have several times done valet parking, that the car can park itself and you put it on the watch and it comes out to you and pick you up. I am living in Aachen. We have 2 e-mobility companies, Street Scooter and Ego, and they work with actually Bosch, I think, for self-driving parking houses. So, think about that. Instead of driving in the car, you just leave it on the valet parking and go away, and all cars go in and park themselves. You save time. But the parking places can be much, much more efficiently used, because if the only cars driving in the parking house is without people, you don't need to open the doors. You can park in 3 lanes, because the parking house can actually remove 2 cars to get you out. You can have elevators instead of ramps of driving. Great, great opportunities here for the parking industry as well. But again, I think that if you see this general for companies that jump from 2 to 4 actually loses. Why do I say that? Because if you don't capture the value of easier decision-making for people on the step 3, your competitors will. Your competitors will earn more money, more profit, spend that in R&D, and actually overtake you to 4. Okay. So let's see what this actually impacts then on technology trends. So I want to talk about 3 topics that I think is the most important right now: closed loop lifecycle management, augmented reality, and innovation platforms enabling digital twins and machine learning and analytics. So let's start with closed loop lifecycle management, because I think that's in the essence of what is actually driving Industry 4.0. So before that, let's start about Industry 3.0. So typically, if you wanted to make a car, you had an idea to the left, you sketched it up, you made maybe a clay model, then you followed a quality gate, waterfall project, and then you had start of production, and you started to produce the cars, hopefully not recalling too many. So yeah, this is the way we have done for many decades. So typically, in Industry 3.0, it's in the 1950s. It's still very few that have mastered this. So typically, the car industry built a platform for 10 years, and then they did annual facelifts every year on this, according to the systems engineering V model, breaking down the requirements and then integrating them up for a validation. They did this in concurrent engineering for the skills of software, electrical, and mechanical. They did this for design for manufacturability and design for serviceability. So this is where the 10-year platform come in. So this is basically Industry 3.0. I think that there is still design optimization and optimization to do to the V model. Very few have mastered this, I think, in perfection and all possibilities. If you look on the best of best, I think everyone can improve on the green area. Now, the first mind shift change we need to take is that instead of a waterfall model, what if we put the car in the center? What if we were an agile company and, developed with Scrum and having evergreen methodology? So we didn't have 10-year platforms. We didn't really have annual facelifts in a structured way. So this is, quite mind-blowing, and I will have to leave it with this, because otherwise Petra will be very upset about my timekeeping. But this is not a trivial topic to put the car in the middle. The first thing is that we add connected manufacturing, connected operations, and connected services on top of this. So now you're starting to see why I mean closed loop. But these are physical activities. You have a physical factory, you have a physical car on the road, and you have a physical car that needs to be serviced. But actually, if we now have smart connected operations and the systems of systems, are we not obliged to actually design this for our customers? I think we should. Are we doing that today? Yeah, depends. So now to the next step of Industry 4.0, let's take the last step of how the tractor changed, the systems of systems. So in the case of cars, this would not be farming, but it would perhaps be a smart city. And in the smart city, this is mobility. It's not the cars. The car is just the physical hardware to provide mobility for people. But mobility is much more. It's also transport of goods, and it is waste disposal and things like this. All of this needs to be optimized. How do you recharge your car? I mean, it's an electrical car. It needs a charger. How do I park in the smart parking house? How do I design my car to work in the mobility system? So this is the physical and digital convergence. We talked about human-centric decision-making, and this is actually so important for us that we have made it our logo. So you can see a stylistic D in green and a stylistic P on top for physical. And this is then basically what we have researched. So in the material after, you can find the link of registering and downloading. So for Internet of Things, how does it change competition, and how does it change how company organize? So bringing physical information into the digital world to do something with it. But it's also, how can I take the digital information and let it make more sense for the people? And we believe that one of the most powerful future are augmented reality. And surprise, surprise, that's my next topic. So we see that data can create a cognitive overload. We get too much data today, so we can't really do good decision making. And if you think about the implications of a closed-loop lifecycle management and the data it actually already has and the data it actually can create, the values of IDC is perhaps even too low. So how can we overcome the cognitive overload that all this great data are upon us and can do? So to not cognitively overload you, I understand this is a fairly heavy presentation in itself. I have a question. So how long has electronic augmented display hardware been around? So I want everyone to do hands up on at least 5 years, because the answer is yes. So who believes we have had AR hardware for at least 5 years? Okay. Yeah, you need to keep them up, I'm sorry. It's just to get blood down to your brain so that you don't fall asleep, because I think that's upsetting for me. Yeah. Okay, so when you take the hands down, then you think, okay, now it's gone too far. So how many think that it has actually been more than 8 years? More than 10 years? More than 20 years? More than 30 years? More than 40 years? Actually 50 years. Okay, so 2, 3 people? 4, 5, 6, okay, a cloud there. So, okay, about 10. It's actually right. We have had this for 50 years. Looked a little bit different then. Maybe not that useful in practical life. But actually, Ivan Sutherland started in 1968 to research of an optimal display system and actually it is augmented reality for 2 eyes, visual, 3D, and so on. But of course, that was not so industrialized. So what we see today is in the near future, this will actually do a lot much more. So basically, it's putting the human in the center. Augmented reality only makes sense for humans, not for computers. But it allows us to get superhuman powers. Actually, even build a sixth sense of all the data around us in this physical digital convergence. And basically, together with an innovation platform and augmented reality, you can overcome time and space. So let's take it down a notch and say, typically when we did user interface designs today, we are limited by technology. If you take the car again, which seems like an ongoing theme in my presentation, is that a separate physical and digital world today, you have your navigation system on the screen, and you need to look up, look down, look up, look down, understand what the digital representation try to see in the real world. I mean, I'm a proud driver, so it's hard for me to confess, but sometimes I drive wrong, even if I have a guiding system next to me. So, and it annoys me when I need to go back and it redirects me, but it's because the user interface is not optimized for my perception. We believe that with augmented reality and the converged world of digital physical, we can provide human perception for decision making that is optimized because we overlay exactly the road that you see in front of us that you need to take in. And even I would actually be able to make this right turn. So what's the industrialization of augmented reality? It's actually huge, and it's actually already ongoing. So we did a research in our trial programs for augmented reality where they would like to go next. We did this a few years ago. And they want to apply augmented reality across all value chains of a company, starting for product development with digital design reviews, going all the way to the right to human resources for job-specific trainings. If you look for a welder, maybe you can do that without gas in augmented reality to see the results, saves costs, and increase quality and the training speed. But all in the middle. So now, are there any money in this? I said I was going to talk about the benefits. Yeah, the benefits is actually huge, especially for work-intensive assembly stations. So one of the first that did an ordered study was wing assembly of Boeing in the United States. So they get 30% faster of designing a wing based on, traditional way with augmented reality. But many gets up to 50% productivity improvement. However, this might not even be the most important. What is it saying? 50% productivity improvement of assembly work not being the most important? Yeah, I mean, we have a quality aspect, the first time right rates. So, but even more, we have with Microsoft done an example with BAE Systems doing batteries for automotive. so basically, what they also see is that creating the augmented reality, because you have the CAD data, is 1/10 of the cost of doing manufacturing drawing and manufacturing preparations. Okay, so the last technology trend is the innovation platform. So what is an innovation platform? So we define this in this fairly complex picture. So it's about how to source data, how to contextualize data, how to synthesize data, orchestrate the people that needs to be involved, and engage the people in the most compelling way. AR, computers, or smart pads, smartphones. Depends on what your needs are. There are different optimal ways, cost versus efficiency. So sourcing data, we have an abundance of the data. We have ERP systems, product systems, PLM systems, but also hardware like the tractor or the manufacturing machines or hardware. So it's both IT systems, OT systems, or actual equipment that we need to take the data from. Then we need to put this data in some type of context. We need to model the thing. We need to model how this data actually relates. So an easy example in your case is typically you have a product structure with the product specification and data, but you also want to have actual costs from the components. They typically come from 2 different systems, but it would be nice to combine them. So this is the contextualize. The synthesize is, can I do decisions as the machine? Can the machine do decisions before I show it to a human so that I can help the decision making? So if you look for predictive maintenance, for example, if I get 30,000 data points, that probably will mean very little for me. But if I get 3 data points, that machine 1 will go down in 5 days if I don't change the roller bearing, 3 data points, I can actually act much better on my services execution. So this is the synthesize, and this is also how we bend the place and time. Orchestrate is, we typically have cross-functional teams and more people involved than we have had before. So how do we involve the right people? Typically, we don't know even who needs to be involved. We need to actually get that from the data to find the people as well, and then to engage. So persons that believe that the digitalization is to go from source to engaging with a nice user interface is sadly mistaken. This innovation platform is the only way you can do digital twins. We call it PLM 720. We don't think you can do a digital twin that fits every purpose. The digital twin for manufacturing is different than the digital twin for services. So how do you do this? You can't do a big digital twin that is trying to do everything. You need an innovation platform to actually provide the digital twin you need for the decision making that you are looking for. Another failure mode, I think, is when you do analytics or simulation as point solutions. Yeah, you can analyze and simulate with good people, but that's not digital at scale. I mean, you need the innovation platform to leverage the full potential of this. I mean, today we can do CFD analytics of fluid pumps in real time and put that into the digital twin context and actually help the services technician rather than waiting 3 months for the simulation team to have run through the simulation. Much more on this topic. Now, in Germany, where I'm from, Aachen, the largest technical university, they have built a reference architecture, so making it more helpful for the German industry to faster put this in place. So this is not ours. This is a source from RWTH and WZL and academic areas, but you see quite good similarities. Sourcing in the middle, a middleware, put it in context, and then engaging. So we also see type of the orchestration, what we call the development cycle, the production cycle, and the user cycle. So in Aachen, they are starting to do smart clusters of actually showing what this can mean for the industry. So for example, in the development cycle, in a car, even more important for an electrical car than the cost of a component is the weight of a component. So building with the simulation and calculating the weight after the design changes, you can quite easily get the plan versus actual breakdown of all the weights of the components of your car, and then have a performance-driven design meeting and reviews. The next step is the production cycle. So you can do a full factory digital twin. We are doing this with a partner of ours, Elisa in Finland. It's quite nice. Elisa is a telco operator. So they started on internally optimizing how to do operations of their mobile networks. And this, they said, we can actually sell as smart manufacturing or virtual manufacturing to customers. So they partnered with us, so they can, in just a few weeks, do a sprint and doing a full factory digital twin representation, as you see here in 3D. It's showing the C part library here from the ERP system, but it shows the status of the machines. It shows the work in progress of how stuff are moving. And I think this is actually, the impact of this, we shouldn't underestimate, because what eGo do, the e-mobility company, is basically saying that we build smarter factories that can produce up to 20,000 cars. But we don't do any body in white, we don't do any painting. We have changed it to a carbon supply. We have pushed out that to suppliers. And so they showed that they could develop a car in a year and another model in a year because of a modular architecture. So they have proven that the barrier of entry in the design phase of car industry for e-mobility is gone. Typically, the 10-year phases was driven by the combustion engine technology. In the electronic world, that is not the case any longer. But even more, scary, if you're in the automotive industry, is that they have also broken down the barrier of the production capacity. Because they have now the definition and blueprint how to create the factory, building information management and building management systems. So they can franchise this. Instead of franchising a McDonald's, you franchise an e-mobility factory that can sell up to 20,000, locally produced, digital lean. If they have an improvement idea in one factory, because they have this full factory digital twin, they share that with the ecosystem. So this ecosystem will improve much, much faster than traditional factory places. And this is then outsourcing your factory capacity because you have the digital information. It's also impacting users. So we talked about the digital twin. So we can today simulate exactly what the car is doing, with comparing the sensors with the simulation results and see if they are the same. If they are the same, it's good. If they're not, we need to improve our simulation. Typically, reality wins. So we did this case with a racing car and showed the force factors on the structural components in the car. And just after watching this video 45 seconds, the head of engineering could see a problem and solve that he hasn't done in his entire career before. A lot of things happens here. So in the mobility company, they are now starting with an ego mover. So they can do a self-driving bus with suppliers and from US and Germany. And they do model-based systems engineering because in the self-driving world, you need to simulate much, much more for the smart city and the systems of systems. So very soon, I think we will proudly present how to do model-based systems engineering with autonomous buses. So how do they work when it's not only one, but there are several? How do you have people go from one bus to another? How do you do transport of goods, etc., and so on? And all of this requires a better simulation to improve the quality virtually, because you can't have all test cases covered as you did in the traditional way. Okay, back to Tacton. Also a very easy use case is to show variants in fares virtually or on products. So we believe that the customer-facing perception brand is extremely important, but we will also have other speakers talking about this today, so I didn't want to steal the thunder. Yeah, technology can do it, then you need to put it in a business context and have a customer centricity. So I'll speed up a little bit. How can we make it happen? But you have other speakers talking about this, so it's okay. I'm going to be very short on purpose. All this is great, but as Henry Ford said, vision without execution is just hallucination. I mean, we can hallucinate of having self-driving cars, but it's actually quite hard to get to what I showed in the previous sections. So the monetization principles are easy. How does a company earn money? Hasn't changed. You can have strategic differentiation and sell more, or you can do it to a lower cost and earn more. But basically, these truths are also true in any type of digital transformation. Now, let's put the customer in the center. I mean, this is only for one ecosystem, for one customer segment, so it's simplified. But typically, you can see the value provided to a customer is done by daily operations. It could be mine, it could be yours. I mean, daily operations does not need to be from one company, but one company can have many daily operations. So this is one way to say how we provide customer value from day to day. But now look about what I talked before and think about the digital backbone and the digital front end. And I call this an ecosystem innovation platform, because it's not Lord of the Rings, it's not one to rule them all. As Microsoft said in Boston this summer in our conference said, to do this ecosystem innovation platforms, it typically takes 20 to 25 partners. because you need the expertise that are the best, and then they need to fit and work together, preferably not only in your company, but with other companies supporting the same ecosystem. Okay, let's focus on the daily operations. Customer is important, but he's still there to the right, and we need to move from the end product from the right to the left. But the time goes from left to right in this picture, but the importance comes for customer first. So daily operations is basically to provide business results based on a business infrastructure. Quite trivial. The tricky part is the digital transformation. We need a digital lean team to do continuous improvement with agile sprints, with a proof of value. We can't get stuck on technology. We need to get into the business impact. Otherwise, this sprint methodology will not work. Therefore, you need an innovation factory. How can I assess, discover, and accelerate? How can I use the state of art? I need to see what's possible, and I need to put this into a roadmap. The innovation factory does not need to be yours. It could be the Stena Industrial Innovation Center in Gothenburg, or customer visits, or the AUGMENTED visit, or other visits. So I think you should take the input from several innovation factories. Now, you need to put a transformation office on the top, and doing infrastructure enablement on the bottom. So basically, this is the ABC, aspirational, sponsorship, and goal definition, business-driven use case delivery, and continuous improve digital at scale for a sustainable pace. So define, deliver, sustain. This is important for the pace, because this is a marathon. This is not a sprint. You can do one sprint, but the one that will win the marathon is the one that can put them together faster than competition. So basically, thank you for your time. I wanted to share the analyst reports on innovation platforms, so a little bit bragging from our side. We are positioning quite well, or on the top, on most of them from that one. So Petra, do we have questions on answers, or timekeeping?
Am I on? Oh, yeah, I am. Thank you very much. That was super interesting.
Thank you.
And a little bit scary.
Yes.
Because, I mean, will there even be work for us going forward, or are we obsolete?
It's a good question. It's one of the questions that the politicians most frequently ask PTC. If we talk about the third industrial revolution, it was about automation. So we did the continuous improvement, lean, Kaizen, or whatever we call it, already in the 1950s, in the first start of industrial revolution. Japan talked about dark factories in 1960. Tesla actually mentioned that one of the failure modes that they admit to this year is that they tried to automate too much. They didn't use the flexibility of the operator. So in the fourth industrial revolution, I think it's about doing the operator to be a superhuman, and that will be more flexible. So I do think it will be work for us for some time, but we shouldn't underestimate the social impact, because the C3POs might be on the horizon. But I think, was it Arthur C. Clarke? He said, actually, as human beings, we want to get the boring work gone. We don't really want to work. We want to spend that on arts, music, and science. So it will be a cultural shift after a while, but hopefully we can take it into our own hands and do the technology to suit humans and not humans to adopt to automation.
Okay, so we can feel secure for now.
But not too much.
Not too much, a little bit. And I have one more question for you, and that is, I mean, all of this is super good, but it seems really big. Yeah. So is like transforming to Industry 4.0, is it just for larger businesses, or can small and mid-sized businesses do it as well?
Yeah, it's a very good question. The blunt answer is, if you don't do it, Microsoft will tell you tomorrow how you will end up. so yes, you need to, but it's harder as a small company. If you are like Scania or BMW and so on, you can do large investments. Smaller companies cannot do this. But if you see on the Industry 4.0 investment from Germany, they are aiming to do this for small and medium-sized businesses. So I think that the social system needs to support the infrastructure on SMB sides. So you have a Wallenberg donations and so on in Sweden and so on. But I think it's hard for small and medium-sized companies to do this without an innovation cluster or actually getting some support from others.
Okay. Well, thank you very much. And you will be here all day today.
Yes.
So if you have questions or wants to discuss something with Kent, he is here. So just find him during one of the breaks, the lunch, or the mingle.
Yep.
Right? So thank you very much.
Thank you, Petra.
Thank you.